All right, back again. Particular solutions. This is something similar. Remember to Unit 10 last year, like 10.4, where it was like a 5-point problem on the AB test. This here, this particular solution stuff could still appear on the BC test. It's not every year like it is on the AB test, but it could appear. And so we got to make sure we know how to do it as well. All right, so we're going to use constant of integration C, and must be included any time we integrate with a indefinite integration, right? And so this because the antiderivative is a family of solutions, and so therefore in order to find the actual value of C, you must know the initial condition. So in this case, what we're going to take is we're going to find a particular solution where an constant of integration is known because of that initial condition. All right, we're going to find out what C actually is going to be. There's only 2 problems here, and that's it. And it's another short video. Dang, I'm a boss here. Find the particular solution that satisfies that initial condition for the derivative of f equals 1 over x squared. X has to be greater than 0. And so I'm going to say, okay, I'm going to integrate 1 over x squared dx. Okay, this is really x to the negative 2 dx, which is equal to x to the negative 1 over negative 1 plus some c. Right, so I can say, okay, well, this is really equal to just negative 1 over x plus some c. So what I want to do is say that I want to now, this is going to be equal to f of x, right? So this is technically our original function, okay? But we don't know that c value. I want to find that c value. So here's what I do. Since f of 1 is equal to 0, I know that y is 0 and x is 1. So I'm going to say, okay, it's negative 1 over 1 plus some c is equal to 0. So c is just equal to 1 once I solve for that, right? And so then I can say that the original function, by way of finding c, is equal to negative 1 over x plus 1. That's all we're doing. That was an easy one because it's just x squared. It's nothing too crazy with e's and ln's and stuff, and we'll get into that later. But so this is an easier one right there, right there. Let's get into the next one. Find a particular solution given the following conditions. Oof, this is going to be amazing. So we know that the second derivative is 2x plus 3. We know there's an initial condition with the first derivative and then an initial condition with the second derivative. And so I wanted to make sure that I'm able to find out my original function. Okay, so if I know the double derivative is equal to 2x plus 3, then I'm going to take the 2x plus 3 and I'm going to differentiate it. Okay, and this is going to give me f prime, right? And so when I do this, I get x squared over 2 plus 3x plus c. Okay, so this is equal to the first derivative. All right, let me just make sure. No, I don't get x squared. I get, oh yeah, x squared over 2. Oh yeah, shoot. This is actually, let me erase this. Hold on. This is actually just x squared, okay? I forgot to divide by something else. So it's just x squared plus 3x plus c. Now I know that f prime of 2, which is x, and then 8, this is y, I can plug that in. So this is 2 squared plus 3 times 2 plus c is equal to 8. Now I'm going to solve for c. So that's 4 plus 2 is 10, minus that over, so c should be negative 2 if I did my math right. That is true. Then, so we know that f prime of x is equal to x squared plus 3x minus 2. Now I'm going to integrate that to find out what my original function is, right? And so when I do that, I get x to the third over 3 plus 3x squared over 2 minus 2x plus c, which is equal to then f of x, which is my original function, which is what I want to try to find. But I still got to find the c value. But now I have an original or an initial condition from the original function at x is 2 and y is 0. So let's plug that in. So 2 to the third over 3 plus 3 times 2 squared over 2 minus 2 times 2 plus c is equal to 0. So this is just 8 over 3 plus, that's 4 times 3 is 12 over 2, which is 6, minus 4 plus c equals 0. When I do that math, I get c is equal to about negative 14 over 3. All right, negative 14 over 3. So therefore, we get, let me do some erasing, cool beans. Therefore, we get f of x is equal to x to the 3 over 3 plus 3x squared over 2 minus 2x minus 14 over 3. And there we go. That's it. So this is your original function. So if I were to take this function and take the derivative of it twice, we will get 2x plus 3. Okay? And we can get 2x plus 3 a lot of different ways, but it's the only equation, or the only original function, that will meet both of these initial conditions, along with giving us the double derivative as 2x plus 3. Okay? That's it for this one. On to the next one. Deuces my gooses.